In math, we use the word polynomial to refer to an expression that has one or more terms added and subtracted with each other. Polynomials usually involve a variable like x raised to different powers. Some examples of polynomials are x squared plus 2x plus 1 and 6x minus 3. Some polynomials may even include more than one variable, like the polynomial 2x squared y squared plus 5x plus y. In this lesson, we are going to talk about how to determine the degree of a polynomial as a way of classifying them. When we say the degree of a polynomial, really all that we're talking about is the value of the highest exponent in that polynomial. For example, in the expression 5x cubed plus 9x minus 2, we can see that the highest exponent is 3. Because of this, the degree of this polynomial is 3. Similarly, in the polynomial x to the 5th plus 100x to the 4th, we can see that the first term, x to the 5th, has the highest exponent. The second term has a much higher coefficient, 100, but we are only concerned with finding the value of the highest exponent. As a result, we know that the degree of this polynomial must be 5. Determining the degree of a polynomial can sometimes help us determine what kind of shape that polynomial would make as a graphed function. For example, a polynomial like f of x equals 4 has degree 0 because there are no x's in it at all. Polynomials of degree 0 are classified as constants, and we understand that 4 is a constant because it is a fixed value and has no variable. Such a graph looks like a flat horizontal line. A polynomial of degree 1, such as f of x equals 2x minus 1, is called linear. The graphs of linear functions are always straight lines, as the word linear suggests. Polynomials of degree 2 are classified as quadratic functions. Interestingly, the word quadratic comes from geometry and relates to the area formulas for quadrilaterals. Whenever the sides of a quadrilateral were expressed in terms of x, the equation for the area of that shape would come out in the form of a polynomial of degree 2, like the expressions x squared plus 4x. On a graph, quadratic functions take the shape of parabolas, which are U-shaped curves. For example, the polynomial f of x equals x squared plus 4x has degree 2, and its shape is a parabola. Finally, polynomials of degree 3 are called cubic functions. You may recognize the word cubic as a variation of the word cube. We can understand this connection because the volume of a cube is equal to the side length cubed, a polynomial of degree 3. On the Cartesian plane, cubic functions tend to look like stretched out sideways s's. Here's the graph of the cubic polynomial f of x equals x cubed minus x. Polynomials may, of course, go to degrees higher than 3, but we will save those for another day. We now know how to determine the degree of a single variable polynomial. At the beginning of this video, I briefly mentioned polynomials that involve x and y. Such polynomials are called multivariate polynomials because they have multiple variables. Fortunately for us, we can determine the degree of a multivariate polynomial by again looking for the term with the largest exponent. The only difference is that we are going to add the x exponent and the y exponent together for each term. For example, the polynomial 3x squared y to the 5th has degree 7 because we add the 2 in the x's exponent with the 5 in the y's exponent to get 7. Similarly, the term 7x cubed y has degree 4 because we add the 3 in the x's exponent with the understood 1 in the y's exponent to get 4. For polynomials with multiple terms, we need to determine the degree of each term and then locate the highest degree. In the multivariate polynomial 3x y to the 5th minus x to the 4th y to the 4th plus xy, we can see that the degree of the first term is 1 plus 5, or 6. The degree of the second term is 4 plus 4, or 8. And the degree of the last term is 1 plus 1, or 2. Out of these, 8 is the highest. As a result, the degree of this polynomial is 8. We now understand that the degree of a polynomial is simply the value of the largest exponent in that polynomial. This is fairly simple with single variable polynomials. With multivariate polynomials, the degree of each term is equal to the x's exponent plus the y's exponent. And the degree of the whole polynomial is again the largest of these. I hope this video was helpful. Thanks for watching and happy studying.